Now we will begin the section 5.3, the binomial distribution. The binomial probability distribution is a widely occurring discrete probability distribution. One characteristic of binomial distribution is that there are only two possible outcomes on a particular trial or an experiment. I mean, only two. We have success or failure. For example, the statement in question do true or false, either true or false, only two outcomes. Note that the outcomes are mutually exclusive, meaning that the answer is true or false can both occur in the same time. Another example may be a product classified is acceptable or not acceptable. So in a quality control. So the classification may not impossible to be the same at the same time. Frequently, we classify the two possible outcomes as a success or failure. So we use the term success or failure a lot in the binomial distribution. But success or failure doesn't mean and don't imply that the outcome which have success is good, but that I want to and interested this output. Not success means that is only good and the other one would have failure is bad. Never. Just success that mean that I interested in this output. Another characteristic for the binomial distribution is that a random variable result can counts. That is the count number of success in the total number of trials. When we flip a pair 5 times and count the number of time of heads a pair, selecting workers in a company, select 20 boxes from any product. These are all examples for countable trials. And the very important characteristics in the binomial distribution is the probability of success remains the same in each trial. The success not differ from one to the other. And the final characteristic that the probability in the binomial probability distribution is that the trials are independent, and it's very important point. We have independent means that there is no pattern in the trial, and the outcome of a particular trial doesn't affect the outcome of any other trial. Okay, so what we say is summarized in this table. There must be fixed trial, and the two outcomes should be reduced. We have only two outcomes, and the trial must be independent and remain, and the probability of success remain the same. So the outcome of a binomial experiment and the corresponding probabilities of this outcome are called binomial distribution. The notation for the binomial distribution is described in this table. P of S is the sample for the probability of success. B of F is the sample for probability of failure. And P is the probability of success. And Q is the complementary rules that we have discussed in the previous chapter. Is the complementary for the probability of success, which is the probability of failure, which is equal 1 minus P equal to Q. N is the number of trials, and X is the number of success in N trials, where X is in between 0 and N, and X take a certain values that are discrete values, 0, 1, 2, 3, not in a range, not in decimal values. There are discrete. The binomial, the probability formula here is P of X equal to N factorial divided by N minus X factorial multiplied by N factorial. If you use this and recall the counting rule that we have studied in the previous lecture. We find this formula is formula for n combination x. So we can write like this, numerator and denominator, or we can write it n combination x. May say we can write c n combination x instead we like this, or we can write like this n, okay, and here x, and there. You can write like this, or write this, or write it like a numerator and denominator. It's up to you. And this is the first part in the probability distribution formula. The second part is multiplying the probability of success to the power x, which is the number of trials, and multiply the complementary, which is the probability of failure, to the power n minus x. So this is the rule for binomial probability distribution. Let's take an example. A survey found that 1 out of 5 Americans says he or she has visited a doctor in any given month. If 10 people are selected at random, find the probability that exactly 3 will have visited a doctor last month. In this survey, we find the values that we are interested in to calculate the binomial probability distribution. Let's first begin with the requirements as we studied before in the previous lecture. We first should determine what we want to calculate. Here we want to calculate the 3 visited doctor. So we have an experiment, and the experiment this have 2 outcomes: who visited the doctor or not visited the doctor. So we have a success and failure. We have our 2 outcomes from this trial. Then we can consider it as a binomial situation, because we have 2 groups of people who visit the doctor or didn't visit the doctor. And select a sample, 10 persons, and we want to determine the probability distribution for who visited the doctor. So the success for us here and the value of P that we want to determine is, and interested in, the number of people who visit the doctor. So the value of P here and the probability of success here is the number of people, or we are interested in number of people who are visited the doctor. Let's then get all the samples from the data given. The number of random sample is equal to 10. Okay, 10 is the random who are selected at random, n equal to 10. Then get the number of x, that the values of success that we are interested. We are interested in exactly 3 who visit the doctor. X equals 3 in this case. And then the probability of success. We want to determine how many people to visit the doctor. So we recall again, reading again the example. A survey found that 1 out of 5 say he visited the doctor. He or she visited a doctor. So the probability of success, or the probability of visiting the doctor, because the visit the doctor in this case is success for us, is equal to 1 over 5. And the rest, which is the complementary rule for us, equal to 4 over 5. Now we are ready for substituting in the binomial distribution formula, which is n factorial divided by n minus x factorial times x factorial over p to the power 3, the number to x, and q 4/5 to the power 10 minus 3 n minus x to the power 7. So the value will be 0.201. So here is a probability with 2.201 that is a random sample of 10 people, exactly of them visited a doctor. Another example is a survey on employment. A survey from teenagers research found that 30% of the teenagers consumers received their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that at least 3 of them will have a part-time. So we find first we should find the value of n, the value of x, the value of p, the value of q to substitute in the binomial distribution rule. First, why we know that is a binomial case? Because the survey divided into 2 parts, success and failure. And I mean the jobs or that have part-time jobs, teenagers that have part-time jobs and don't have the time, not have part-time jobs. So the number x is at least 3. At least mean greater than or equal 3. Greater than or equal 3. So we should add up the value 3, probability of 3 because the equal sign, and greater than, so probability of 4 and probability of 5, because we have only 5 teenagers selected at random. So the total number of x's here up to only 5. Then we have x calculated a probability of x when x equals 3 and the p of x when x equal 4 and the p of x when x equal 5, and adding them all up. The value for the success or the number of people who have part-time remains the same in the 3 times or the 3 cases, because it's equal to 30%, p equal to 30%, 0.3, and we will take a total sample size in factorial n over n minus x multiplied by x factorial, and p equal to 0.3 and the complementary equal to 0.7 to the power 5 minus 3 equal 2, and substituting in the binomial distribution rule and get the values in the 3 cases and adding them all up, hence we find the total value. Now the final step in this distribution or the discrete distribution, binomial distribution, how to get the mean, variance, and the standard deviation for the binomial distribution. Actually, we have 3 rules. Mu is the mean for the binomial distribution equal to the sample size n multiplied by the probability of success, and the variance for the variance is equal to the variance equal to variance equal to sigma square n number multiplied by the probability of success multiplied by probability of failure or complementary for success. And standard deviation is the square root for the variance sigma square. Let's take an example. The example of tossing coin. If the coin tossed 4 times, find the mean, variance, standard deviation. Of course, we know that when we tossing coin, the probability of success that we interested in here, heads, number of heads may be in each case will be half. And the n, the number of random trials is equal to 4. So the mean will be n times the probability of success half equal to 2. This is for the mean. Then find the value of q of sigma square is equal to n times p times q, which is equal to n4 times half equal to 1. And finally, the standard deviation is the square root for variance equal to 1. Another example, an 8-sided die is rolled 560 times. Find the mean variance standard deviation of the number sevens that will be rolled. That it's a binomial experiment. Why it's a binomial experiment with n? Because that it hides it's that we are interested in the 7 that will be appear. So if we have 7, this is a success for us. If we haven't 7, this is a failure for us. So the probability of getting 7 only 1 over 8. The die, note that the die here is 8-sided. 8-sided, not 6-sided. So the probability of success here will be 1 over 8 because we are interested in the number 7 only. And this is a success for us, and all the other values become failure for us. So the complementary is q, what's the probability of failure, equal 7 over 8. We can now use the what is the requirement is what is the mean mu, not mu square, sorry, it's mu only. Mu equal to n times p, which is equal to number of tossed times or rolls time 560 times 1 over 8 equals 7. Now sigma square is n times p times q equal to the 61.25, and finally sigma equal to root variance equal to 7.826. Another example, likelihood of twins. A statistical population published by life insurance company reported that 2% of the all-American birth results in twins. If a random sample of 8,000 births is taken, find variance and deviation of the number of births that would result in twins. It's a binomial distribution situation because we are either twins or not twins. If we know the result, what the two types only, twins or not twins. So we have two outcomes. So it's a binomial distribution, and to get the mean, we can multiply the total sample taken, 8,000, and by the probability of getting twins, because we are interested in getting twins, which is 2, and this is the success for us, and get the mean value mu equal to 160. And the variance in this case will be the total sample size taken, 8,000, times the probability of success, 2%, times the probability of failure or not twins, which is 0.98. And finally, we get the standard deviation, which is the square root of the variance, and 12.522. Here, up to this point, we already finished our lecture today and take the probability distribution. The first type is a binomial probability distribution. Please study well and solve the following exercise that covered all what we studied in this lecture. Study well and then solve this exercise